We used the decorator design pattern to extend the built-in Antler classes, overriding only the methods that we needed to implement. By using the decorator pattern, we were able to make the most efficient use out of the interface the Antler provided without the need to write additional adapters. The most important design consideration we made was the language that we used to interact with Antler. We chose to use Java because the benefits were so much greater than the costs. First, Antler natively supports Java, so we did not have to write our own adapter to the Antler interface. Secondly, there were many Java-based examples in both the Antler docs and Dr. Parr's reference book. In exchange for those benefits, we accepted Java's greater system resource costs than other languages, such as C-based, and the need to recompile the package each time that a change was made, which is something that we wouldn't have to do with an interpreted language, such as Python.
One unique aspect of our project compared to other compilers is that we built a symbol table class, which holds all of our methods for creating and manipulating the symbol table. This decluttered our listener class, which made it easier to understand what was happening and which parts of it were for the symbol table. We used this to our advantage in order to create our own methods within the class, which were accessed through the listener class. Doing this saved us lines of code and improved our understanding. Our future work would include fully completing the project. Due to the circumstances, our team was not able to get a working implementation of a compiler. We would complete it by going back through and making sure that each method is implemented correctly and that we are not missing functionality. Beyond completing the compiler, we would like to do code optimization. We would want to focus on common sub-expression elimination and register allocation. Replacing repeated operations with the variable that the solution already lives in will improve the readability of our program, as well as increase the speed. For this assignment, we were allowed to assume infinite registers exist, but this will not be the case in most situations, and also slows the program down drastically. We would allocate registers more sparingly so that it would be functional in a real-world environment.
For communication after everything went online, our team mostly used Slack, group text, and Zoom. Slack for the technical communication, group text for important updates, and Zoom for pair programming and immediate conversation. The software lifecycle model that we used was the iterative cycle. Since each step was already broken down for us, we didn't really need to break it up any farther. Given proper planning, this allowed us to get everything done perfectly on time, but if we neglected to plan correctly, then there was such a large amount of things to do at the end of the step that we might not have had enough time to complete all of it.